Welcome to our Science Techno channel. So last class we discussed about series resistance and parallel equivalent resistance. When the resistors are connected in series and parallel, and how to derive the equivalent resistance. These are all concepts last class covered, right? So today we have to solve some problems based on series circuit and parallel circuit. Okay, right. So see here, given that problem is find the equivalent resistance for the given circuit and also find current So here given the circuit like this. So here given the circuit, once observe here 2 ohm resistance given, 4 ohm resistance given, 4 ohm resistance given. Here 220 volts voltage given. How much of voltage? 220 volts. 220 volts. Right. Now we are calculating the equivalent resistance. Okay. Before going to solve this problem, first of all, here which type of circuit given? First of all, we have to find that. Here all the resistance are connected in series, right? Here R1, R2 and R3. These resistors are connected in series because of all the resistors are in a single path. So this circuit we can treat it as a series circuit, right? Okay. Now, given that resistance R1 is equal to 2 ohms and R2 is equal to 4 ohms and R3 is equal to 4 ohms. And how much of voltage given? V is equal to 220 volts. Right. Now we are calculating the equivalent resistance Req. Now we are calculating Req and current I. We don't know about the current. Okay. So this is a given data from the problem. Right. Now we are calculating first of all Req. So already we discussed about that. If we are going to solve this problem, first of all, we have to find resistors are connected in series or parallel, right? So here all the resistors are connected in series. Why? Because all the resistors are connected in single path, single way. All the resistors are connected in a single path. So these are all in a single path. So that's why this is a series circuit. Right? Now, so already we have to discuss about in last class what is the formula of equivalent resistance when the resistors are connected in series. That is, already we know that resistors are connected in series. Resistors are connected in series. What about R equivalent formula? Already we know that formula. R equivalent is equal to sum of the resistors R1 plus R2 plus R3. So this is the formula R1 plus R2 plus R3. So already we know that values, resistance values R1, how much? R1 is equal to 2 ohms plus R2 is equal to 4 ohms plus R3 is equal to 4 ohms. So total of how much resistance? R equivalent equal to 4 plus 4 plus 2. So 10 ohms. Finally we get R equivalent. So first parameter over. First one already we could get that value. R equivalent is equal to 10 ohms. And another factor. that is I. How can we calculate the current? How can we calculate the current? Here, before going to calculation of current, first of all we have to know the formula of Ohm's law. So we know that by Ohm's law, V is equal to IR. V is equal to IR. Then I is equal to V by R. Then I is equal to V by R. So this is the formula. I is equal to V by R. Okay, already in this problem, voltage given how much? 220. 220 volts given already. And already we are calculating equivalent resistance, R equivalent to 10 volts. These two parameters are substituted in this equation. Finally, you get the current. So therefore, I is equal to how much of voltage given? 220 volts. 220 volts divided by how much of equivalent resistance we have to find? Already we are calculating equivalent resistance. How much? 10 volts. So 10 volts. 0, 0 cancel. Now finally you can get the value 22. What is the SI unit of current? Amperes. So amperes. So how much of current you can get? I is equal to 22 amperes. So this is a way of the solution. How can we solve this problem if they are giving about this like these problems, right? So this is a very important. So this circuit is only I have to consider only in series only. From the next class, we are calculating the equivalent resistance in parallel and how can we find the current values by the Ohm's law. Okay. Right. Next class we have to discuss about that. Okay. In this class only we have to discuss about in this series circuit how can we calculate the equivalent and how can we calculate the current. Next class we have to calculate the equivalent resistance when the parallel circuit is given and how to calculate the current. Okay. Thank you.